Morning students, I am RD Sharma. I am going to teach you exercise 4.2 from Manjeet Singh Mathematics class 9. Let's solve question number 2. State true or false for each of the following. So we have to check that this statement is true or false. Note, square root 8 plus square root 32 minus square root 2. When we check it square root 2, we have to convert it into the mixed. How we can change it? So first of all, factorize 8. It can be divided by 2 4 times. 4 can be divided by 2 2 times, and 2 by 2. Now it's a square root, so make the pair of 2's. 1 comes out, means there is one pair of 2's. So you can write square root 8 as 2, and this 2 is not in pair, so you have to write in root. It means square root 8 is 2 root 2 plus square root 32. Now factorize 32. You will get, you have to divide 32 by 2, 16, 16 by 2, 8, then divide 8 by 2, 4 times, and divide 4 by 2, 2. How many pairs are there here? It's a pair of 2, second pair of 2, and from each pair you have to take one factor and multiply them. So 2 to the 4, that comes out of the root 4, and this 2 that has no pair will be in square root. So 4 root 2 minus root 2. All the terms have same square root 2. So add the parts which are multiplied with root 2, means 2, 4, and here is 1. Okay, 2 plus 4, 6, minus 1, that is 5 root 2. This is given in RHS, so this statement is true. Okay, so you can solve it like this. Second statement, it is square root 45 minus 3 square root 20 plus 4 root 5 is equal to root 5. So let's check it. Square root 45, so first factorize 45 and you will get divided by 3 15 times, divided by 3 5 times. So it has one pair of 3's. Okay, so take 3 out of it, and square root 45 is equal to 3 root 5 minus 3 multiply and convert root 20 into mixed 20. So divide it by 2, it's 10, divided by 2, it's 5. So 2 has a pair, so you can write it 2 root 5, and next is 4 root 5. Okay, so it is 3 root 5 minus 6 root 5 plus 4 root 5. Take root 5 as common, and in bracket you have to write 3 6 plus 4 root 5. 3 plus 4 5 7, 7 minus 6 1. So it is 1 root 5 or root 5. So in RHS it is given root 5, so this is also true. Okay, this statement is true. It's statement 3. In this question, LHS is 5 root 3 plus 2 square root 27 plus 1 upon root 3, and it has to be proved equal to 34 upon 3 square root 3. Okay, So let's check it. 5 root 3, right, same. 2 root 27, but 27 can be written as 3 root 3. Why? So for this you have to factorize 27 divide by 3, it's 9, divide by 3, 3 times, and it has a pair of 3, so write 3 out of the root, and that 3 has no pair, you have to write in root, plus 1 upon root 3 and multiply it root 3 to get the rationalizing factor of the denominator. So it is 5 root 3 plus 6 root 3 and plus 1 upon 3 root 3. Root 3 into root 3 becomes 3. Now take root 3 as common and write all the parts in bracket. 5 plus 6 plus 1 upon 3 square root 3. Now it's 11 and you can take LCM. So it is 15 plus 18 plus 1 root 3. 15 plus 15, 30, 33, 34. So it is 34 upon 3 root 3. That is the same in RHS. So I can say that this statement is true. Okay. Now you have understood what the question is asking and what is the result. Since both LHS and RHS are coming same, so you can easily say that it's a true statement. Let's go to next question. Fourth statement is on rationalizing the denominator of square root 7 minus square root 5 upon square root 7 plus square root 5. It is equal to 6 minus square root 35. So let's check. You are given square root 7 minus square root 5 upon square root 7 plus square root 5. So to get the rationalizing factor, simply rationalizing factor of denominator is square root 7 minus square root 5. By changing the sign of square root 7 plus square root 5 means you have to multiply it by square root 7 square root 5. Why? To complete the formula a square minus b square. Okay. In a square minus b square, whenever you are given a plus b, then you have to multiply this form a minus b. So it becomes a square minus b square. But when the denominator given in the form a minus b, then you have to multiply by a plus b to numerator and denominator. So in this case, we have to multiply denominator and numerator by root 7 minus root 5. Root 7 minus root 5 upon root 7 plus root 5. It's question. And multiply the rationalizing factor of denominator, that is root 7 minus root 5 upon root 7 minus root 5. Okay. In numerator, the formula is a minus b into a minus b, that is a minus b whole square, and a minus b whole square is equal to a square plus b square minus 2ab. Okay. So by using this formula, you can multiply numerator square root 7 whole square plus square root 5 whole square minus 2 multiply root 7 multiply root 5. Okay, 2ab. And use this formula in denominator, it's square of root 7 minus square root of root 5, square of root 5. Square root of root 7 is 7 plus square of root 5 is 5 minus multiply this, it's 2 root 7 5 is 35 upon 7 minus 5. Now add 7 and 5, so it's 12 minus 2 root 35 upon 7 minus 5 is 2 take common, or you can write 12 upon 2 minus 2 upon 2 root 35. Okay, now cancel it 6 times, 2 1 is 2. So finally answer is 6 minus root 35. That is given in the statement. So this statement is also true. Okay, let's check statement 5. In this statement we are asked if square root 2 plus 1 whole square upon 3 minus square root 2 is equal to a plus b square root 2, then what is the value of, means then value of a is equal 11 upon 7 and the value of b is equal to 13 upon 7. So let's say first of all, in this statement, in this part, means square root 2 plus 1 whole square upon 3 minus root 2. Simplify numerator. So it is square of 2 is 2, square of 1 is 1, and twice the multiply of both numbers. Root 2 into 1 root 2 and its twice is 2 root 2. I am using the formula a plus b whole square and right denominator same. Now rest lies the denominator. 3 plus 2 root 2 is numerator and 3 minus root 2 is denominator. Rest lies the denominator by multiplying 3 plus root. So you can multiply numerator and denominator by 3 plus root. 3 plus root. Now multiply 1 by 1. 3 into 3 9. 3 into root 2 is 3 root 2. 2 root 2 into 3, that is 6 root 2. 2 root 2 and root 2, it's 4. Okay, square of 3 is 9, square of 2 is 2, root 2 is 2. Now add like terms. 9 plus 4 is 13. 13 plus 9 root 2 upon 7. Okay, so it is 13 upon 7 plus 9 upon 7 root 2. So when we compare it with a plus b root 2, then a is equal to 13 upon 7 and b is equal to 9 upon 7. But they are not given in a statement. In a statement is given a is equal to 11 upon 7 and b is 13 upon 7. So you can easily say that this statement is not true, means it is false. Okay. In statement 6, it's given x is equal to 2 plus root 3 and we have to find the value of x minus 1 upon x. Then first of all find the reciprocal of x, that is 1 upon x. So it would be 1 upon 2 plus root 3 and now multiply numerator and denominator by 3 minus 2 minus root 3. Okay, 2 minus root 3. So it is 2 minus root 3 upon square of 2 is 4, square of root 3 is 3. And the difference of 4 and 3 is 1, so you need not write. So answer is 2 minus root 3. Okay, now get solution of x minus 1 upon x by putting the value of x and 1 upon x. So x is equal to 2 plus root 3 in bracket and minus, and 1 upon x is 2 minus root 3, right in bracket because of this sign. Now open the brackets. 2 plus root 3 minus 2 plus root 3. 2 have its additive inverse minus 2 and 2, so you can cancel them. Root 3 and root 3 both are positive, so you have to add them. So it is 2 root 3 that is given in statement. So this statement is true. Okay. यदि वीडियो पसंद आया हो तो प्लीज लाइक शेयर एंड सब्सक्राइब जरूर करके जाइएगा ताकि आपको टाइम टू टाइम वीडियोस का नोटिफिकेशन मिलता रहे. थैंक्स फॉर वॉचिंग.